Hello students, welcome to the Department of Mathematics Anand Ramburwa Academy. I am Azharul Talukdar. I will take your mathematics classes, and in this video we are going to discuss about the chapter permutation, and this lecture this is the lecture number 1. So let us get into the video. So before going to the main topic of the chapter permutation, first of all we are to know about factorial. So what is a factorial? You already know about factorial if you have advanced mathematics in your high school classes. So factorial of some number I am writing here the factorial of a number n. This n should be a natural number. It is a must case. Okay, so this n factorial of n mean a natural number, n should be equal to 1 or 2 or 3 or 4, etc. It cannot be a fractional number, or it cannot be a negative number. Okay, so factorial of number mean the number should be a natural number. So first of all you are to write the definition of factorial, this one. For any natural number n, the factorial of n is denoted by the symbol. This is the symbol of factorial. You see that one? This is the symbol of factorial. I'm sorry. This is the symbol of factorial. The factorial mean you may write in this way, or then there is another symbol you may also write in this way. So this is the factorial symbol, and it is the continuous product of the first n natural numbers. Mean factorial of n will be equal to 1 into 2 into 3 into 4 into and so on, then n minus 1 and then into n. So this is the definition of factorial. Very simple. That means it is factorial of some number. That number should be a natural number, and it is nothing but the continuous product or consecutive product up to first n natural numbers. And this is also written, you see here, this is also written in another symbol. We write pi. This is the capital letter pi, and here the dummy variable is taking I from 1 up to n, and then we write I here. It will represent this thing. As you already know about this symbol summation, I from 1 up to n, you already used this in your high school classes. What is the meaning of this symbol? It is simply 1 plus 2 plus 3 and so on up to n. If you use summation sign, then these terms are add up. But when you write pi, then the terms of the series pi, I am writing here, when you write pi and I from 1 up to n, then the terms should be multiplied. That means 1 into 2 into 3 and so on. Clear? So up to n, the final value is n only. The final value is n. Okay, so I think you understood this part. So you write this these notes in your copy. So this is the definition of factorial sign, factorial, and this is the symbolic notation I already discussed with you. And again you see we can extend the definition of factorial n to the definition of factorial 0. Actually you see 0, this is not a natural number, but as per the definition of factorial of some number, the number should be a natural number, but 0 is not a natural number. Though 0 is not a natural number, it has a value. It is just one and only one exception for factorial. This is exception. 0 is not a natural number, but the value of factorial 0 is quite possible. You see here how to obtain the value of a factorial 0. Before that, you see we have an important property. We have an important property of factorial notation. By the definition of factorial, you see factorial of n, just we know factorial of n, it is the continuous product 1 into 2 into 3 into 4 and so on up to n minus 1, and then finally it is n. But from 1 up to n minus 1, this is nothing but factorial of n minus 1. This is nothing but factorial of n minus 1, and this n is already remaining there, and so we write here n into factorial n minus 1, and our left hand side is already this one. So this is one of the important property of factorial n. That is, the property tells us that is, if we take the number inside of a factorial, if you take that number which is inside of a factorial, uh, if you take that number outside of the factorial, then the number inside factorial will decrease by 1. Here you see, let me take one example. Say I have factorial 6. Then if you take this 6 outside the factorial, then the inside number will be decreased by 1 as per this property. Similarly, 6 is already here. If you take that 5 outside the factorial, then this number is again decreased by 1, factorial 4. In the similar way, if you take 6, 5, then 4 outside the factorial, it will be again decreased by 3, and so on. So this is one important property of factorial, and this property will use to show the value of a factorial is defined and its value is 1. So this is the topic now, definition of factorial 0. So definition of factorial 0 tells us, so you write the notes here, you write like this: we know factorial of n is equal to n into factorial of n minus 1. This is your property, and from this line you can write factorial of n minus 1. This will be is equal to factorial of n divided by n. And already from the definition of factorial, that we know n is a natural number, so we can use the value for n is equal to 1 or 2 or 3 and so on. Any value we can use because n is a natural number. And here for our convenience, we are using the value of n is equal to 1 in this above expression. So you just write putting n is equal to 1. Then in the left hand side, what you will get? You will get 1 minus 1, and on the right hand side you will get factorial 1 divided by 1. But left hand side factorial of 1 minus 1 will give us 0, and factorial 1 is 1 and divided by 1 is obviously 1. So this is the definition of factorial 0. Though 0 is not a natural number, but its value is 1. Okay, so another thing you should note, that the factorial of a fractional number and factorial of a negative number is undefined. You write note in your copy. After that topic you write note. You just write factorial of a negative number or a fractional number is undefined. Undefined means it has no value, is undefined. That is, you write after this, that is, I am erasing this, that is factorial of say minus 3. This is undefined, mean it will go to infinity. Undefined mean infinity, because factorial minus 3, if you use the property of factorial, then if you take this minus 3 outside the factorial, by property it will be minus 4. And in the similar way, if you write minus 3 into this minus 4 is taken outside, then the number inside factorial will again decrease by 1. And in this way, if you go, then never this series or sequence be terminated. It will not be terminated anywhere. Minus 5, minus 6, minus 7, and it will go through up to minus infinity or infinity. That means undefined. So factorial of any negative number, whatever be the negative number you have, it is undefined number. In the similar way, factorial of a fractional number is also undefined. Factorial of a fractional number is also undefined. That is, if you write factorial of say 1 by 2, this is also undefined. It has no definite value. It will be infinity. Any fractional value. So fractional value and negative number value, factorial of those values are always undefined. But in case if in your exam the value of this is asked, say 1 by factorial of minus 4, if you in your exam it is asked that what is the value of 1 by factorial of minus 4, and you should write, you say 1 by, already we know that the factorial of minus 4, it is infinite number, maybe negative number also, that is negative infinity or positive infinity, anything, and infinite number, and this will give us 1 by some infinite number, very big number actually. So 1 divided by very big number will give us 0. So 1 by factorial of negative number, this is defined and the value is equal to 0. Similarly, 1 by factorial of some fractional number, say it is 3 by 5, then also this value is 1 by infinity and that will be equal to again 0. So you got my point, I think. So let me go to the next topic, fundamental principle of counting. This is one important part of this chapter, fundamental principle of counting. Actually there are two principles. One of the principle is called fundamental principle of multiplication, and the second one is called the fundamental principle of addition. So let me write the definitions or write the topic about the fundamental principle of, first I am writing, say, multiplication, fundamental principle of multiplication. This is the first one. So first you write this, what is fundamental principle of multiplication tells us, you write that one in your copy. You see here, you read this one. See, if there are two jobs mean two tasks, you have two tasks to be completed. If there are two jobs such that one of them can be completed in m ways, m number of ways actually, and when it has been completed in any one of these m ways, if the second job can be completed in n number of ways, then the two jobs in succession, this means these two jobs in succession mean after completion of the first job you are to go to the second job. This is called in succession. So then these two jobs in succession can be completed in m into n number of ways, and this is called the fundamental principle of multiplication. So what is the principle tells us? The principle tells us that if you have, it is, I am writing here only for two number of jobs, you may have more than two number of jobs also. So if you have a task to be complete, so let me take one example here for you. You see, let me take one example for you. You see one example. Say you have a room like this. You have a room like this, and you are in this side. You are in this side, and the task is to go from this side to that side of the room. You see here, just a minute, I'm taking this one, just a minute. Just a minute. Say you have a room, this is a room, say, and say you are on this side of the room. You are on this side of the room and you have to go on to this side, and these are the two entrances. So I am writing here entrance 1 and say this is entrance 2, and these are exits. Say this is exit 1, this is, say, exit 2, and say this is exit 3. This, and your task to complete the job by going from this side of the room to that side of the room. From this side to that side, you have to go from this side to this side. Then in how many ways you can go from this side to that side? So you may take the route entrance 1, exit 1, or you may take the route entrance 1, exit 2, you may take the route entrance 1, exit 3. This may be the options for you. Similarly, entrance 2, exit 1, entrance 2, exit 2, entrance 3, exit 3. These may be the different routes to complete your task from going from one side of the room to the other side of the room. So here you see there are 6 number of different ways: E1, EX1, E1, EX2, E1, EX3, E2, EX1, E2, EX2, E3, EX3 are the different routes. Okay, so this is a manual process to finding the number of ways to complete a task. But if you know the fundamental principle of counting, that the first part of the job can be completed in 2 ways. Here you see, if you want to go from this side to that side of the room, then first of all you are to enter the room, then you are to exit the room. So first you are to enter the room, this is one part of the job, and to exit the room, this is the other part of the job. So to enter the room can be entered to the room in 2 number of ways, and you can exit the room in 3 number of ways. So total you will have 6 different number of ways, and these are the 6 different ways already I told you. These are the 6 different ways: E1, EX1, E2, EX2, E3, EX3, and same E1, EX3, E2, EX1, E2, EX2, and so on. These are the different routes you can use to go from this side of the room to that side of the room. So this is known as the fundamental principle of multiplication. So here you should always keep in mind, in case of fundamental, where you are to use the fundamental principle of multiplication. So you should choose the fundamental principle of multiplication when you see in a problem that the problem, to complete the problem, you are to complete the jobs, both the jobs. There may be more than 2 jobs also. If you are to complete both the jobs, then you have to use the principle of multiplication. But if you have to complete either of these 2 jobs, then you are to use the principle of addition. That will I written next. You see here, fundamental principle of addition. So addition principle tells us, you write in your copy, if there are 2 jobs, here also there are 2 jobs such that they can be performed independently. 2 jobs, the first job can be completed in m number of ways, and the second job can be completed in n number of ways. There are 2 different jobs, and if you are to complete either of these 2 jobs, either first job or the second job, either of these 2 jobs, if you want to complete, then you are to use the addition theorem or addition principle. Either this or that. So let me take one example. Say in your class there are 40 number of students. There are 40 students in your class, you think, and out of 40 students, say there are 25 girls student, 25 girls, and say 15 boys students are there in your group. Okay, so if I ask you to select or to give one student to represent some function, say I ask you to give one student from your class to represent some event. Okay, then what you will do? Either you take the student from the girls, or you will take the students from the boys. If you choose from the girls, then you will have 25 number of different ways. 25 number of different ways, because any one of these 25 girls you can choose. Therefore, you have 25 number of ways to choose a girl. And similarly, if you choose a boy, and then you will have 15 number of different choices to select one of the boy from 15. Okay, then the question was what? The question was, I asked you to give one student. I am not indicating here that you have to give a girl student or you have to give a boy student. I am not indicating that. I just ask you, I need one student from in your group, from your group. So obviously you will give either a boy or a girl. So this is either or option, and here now you will have total number of options 40, because you may give from 25 number of ways, and second job you can complete in 15 number of ways. So either of the jobs can be completed in 40 number of ways. That means you have now 40 different ways to choose a student from your class. So this is the main thing about the principle of addition. So you should distinguish the difference between these two, fundamental principle of addition and fundamental principle of multiplication. So multiplication, when multiplication is to be used, when you are to complete all the jobs corresponding to the problem. If you have to complete all the jobs, then you should use the multiplication principle. But if you have to complete either of the given jobs, then you should use the addition theorem of addition principle of addition, fundamental principle of addition. Okay, so let me go to the next topic. This is your main topic, permutation of all different objects. So what is permutation? Permutation means the arrangements of some objects. Here you should note that the objects given or provided to you are different objects. All of the objects are different. That means say the objects are say a pen is given, then a pencil is given, then say a book is given, and so on. These are different objects. Objects are different. Since the objects are different, then how to permute? Permute mean how to arrange. Arrangement mean, what is called arrangement, that is an important part. Arrangement mean, say I am taking 3 digits, 1, 2, say 3 digits we have. If I write this 3 digit in this order, 1, 2, 3, then it will represent a number with valuation 123. But if you write the same digits in this way, 2, 3, 1, then its valuation is different from the previous one. Okay. Similarly, if you write it is 1, 3, 2, it will also represent a different thing. So this is known as permutation. Permutation means arrangement of objects. That means the objects should be selected as well as that they should be keep in a particular order. When the order is a reference of objects, when the order is necessary, then it is called a permutation, and that is mean it is an arrangement. Arrangement means the order of the objects you are keeping is necessary. Okay, so that is the main thing. You see, each of the different arrangements which can be made by taking some of the objects or all of the objects given. Say you have 10 number of objects, all the 10 objects are different objects. All 10, these are different objects. You may take some of these objects, mean you can take 5 or 6 or 7 number of objects, or all of the objects. You may take some of objects or all of these objects taken at a time. Then each of those arrangements is called a permutation. Each of the arrangement, any arrangement, first you select the object, then keep them in some particular order. Each of the particular order maintained is called a permutation. Okay, so that is known as arrangement. So this is the definition of permutation. Now we will write one theorem, very important theorem. The number of permutations of n different objects, if you have n number of different objects and you are taking r of them at a time, n number of different objects you have, now from n objects you are taking r of them. as like from 20 objects you are taking say 15 at a time or all at a time. So some of them or all of them, it is nothing but sum mean from n objects you are taking some of them, that is r of them, or all of them. So that means r should be either less or equal to n. When r is less than n, then you are actually taking some of the n objects. But when you take r is equal to n, then actually you are taking all of the objects at a time. Okay, so that notation, the notation, when you take r objects from n objects, then the notation is n, this is npr, npr, sorry, this is not npr, this is the notation npr, or you may write permutation of nr. This is also the symbol of permutation, npr or p of nr. Here n is the number of objects provided to you and r the number of objects you are selecting at a time. So in case of permutation, when the objects are different objects, then the symbol from n you are taking r, this is the symbol if the objects are different, and it has the formula to find the value of this npr. You are to use this formula, factorial of n divided by factorial of n minus r, factorial of n divided by factorial of n minus r. And how it is equal to this one, we will prove that. Okay, so to prove that one, you see, first you write your notes here. You have m number of objects, so I am writing here, you see, I am writing here the number of permutation of n different objects taken r of the objects at a time is the same as the number of filling of r places by r of the n different objects. So what is this? You see, you have n number of objects. Number of objects is n, and you are taking r of them at a time. That means you are filling r empty spaces. So these are the empty spaces. Empty spaces. First choose r objects from there and arrange them. One of the object is giving here, keep one of the objects here, then here, in this way. So selection of n objects, selection of r objects from n, it can be considered as that you are filling r empty spaces from the selecting r objects. Okay, so that is actually I have written here. I have written now the first place. This is the first place. The first place can be filled up by any one of this n number of objects, because the provided number of objects is n. So the first place you can take any one of this n. That means you have n number of options. So that is the first work can be done in n number of ways. So that is written here, any one of these n objects. Then after filling the first place, here one of the place is filled up. One of the place is filled up. Then after filling this place, you go to the second place. This place is filled up. You see here, this place is already filled up. Now how many objects you have? One of the objects is already taken. So now you have n minus 1 number of objects. Then for the second place, this is your second place. Second place, you have now different number of choice. How many different number of choice? N minus 1 different number of choice. So the first place can be filled up in n ways. The second place, now you have n minus 1 number of ways. After filling the second place, now you can fill the third place in n number 3 ways. Then fourth place in n number, sorry, not 3, this one, n minus 2 ways. Then fourth place in n minus 3 ways, and so on. N minus 3 ways, and so on. So this is the rth number of place. This is rth place. So how many options you will have now? It will be n minus r minus 1. You see here, first one, first place it is n minus 0, second place then n minus 1, third place then n minus 2, fourth place then n minus 3, then rth place mean n minus r minus 1, one less than the place number, so r minus 1. So that can be written as n minus r plus 1, this one, n minus r plus 1. So these are the different options you can choose. Now if all this task is to be completed, so you are to use the multiplication rule or multiplication principle. That means the total job can be done in n into n minus 1 into n minus 2 into n minus 3 and so on up to into n minus r plus 1. You see that one. You see that. So this is the number of ways to fill up the first 3 places. Then continuing this process, the r number place can be filled up in this number of ways, n into n minus 1 into n minus 2 and so on into n minus r plus 1. And how it is n minus r plus 1 I just told you. And so I will do something here. You see the number of ways, what just we have written the total number of ways r places can be filled up in n minus 1, then n minus 2 and so on, it is n minus r plus 1. So this can be written as, you concentrate in the screen of the this way, n minus r plus 1, then what will be the next number? Is it not n minus r? Just decreasing one by one, term by term it is decreasing 1 and so on, term by term it is decreasing. Then next number will be n minus r minus 1 and so on. Finally somewhere it will be 3, then it will be 2, then it will be 1 finally. Then after that no objects will be there, and divided by this whole terms divided by, what are the terms you have written excess here? These are the excess terms. So you write those terms, n minus r into n minus r minus 1 into so on 3, 2, 1, and it is equal to, you observe the numerator. Numerator is actually the product of 1 into 2 into 3 into so on up to n. You see here it is, you see here 1, then 2 into 3, then 4, 5, 6, 7, 8 and so on, going to up to n minus 1, n minus 2, n minus 1 and finally n. So the numerator is the continuous product of first n natural numbers, therefore it is factorial n. And observe the denominator, it is the product of 1 into 2 into 3 and so on up to n minus r. So it will be it is the product of n minus r continuous natural numbers, so it will represent factorial n minus r, and this total part is represented by npr, and that is why npr is equal to factorial n divided by factorial n minus r. So this is the complete proof of the theorem. So you see the next one. Oh sorry, I have written here, you should write all of this in your copy. This one already discussed in the previous screen. You see this permutation with repetition. This is the new topic, permutation with repetition. Mean now the provided objects can be repeated. That means one of the object can be repeated so many times, but in the previous one the objects are not repeated. From n objects you are taking r at a time. No repetition is allowed in the previous theory, but here the permutation of objects which are different objects, but you can repeat the objects, you can reuse the objects. So what will be the effect of the word repetition in permutation? You see that one. First of all, I am writing this topic here, you write in your copy also. Here, if each of the n given different objects, you have n number of given different objects and repeated up to r times. That is, you are taking this time also, you are taking r at a time. You are taking r at a time, but you can reuse the objects. So since you are taking r objects and you can repeat the objects, that means one object can be repeated r number of times, because this time you see, this time you see here, now you are filling r places again here. Say these are the places, empty places you are filling. From n you are selecting r, and one of the object can be repeated. If you use a object here, say one is using here, then this one can also be used here, this one can also be used here, used here, used here, and so on. So total r number, r times repeated. Okay, r times repeat, you can repeat r times. So each object can be r times repeated. Therefore, what is the total number of permutations in this case? R times repeat mean you can repeat one time also, repeat two times, repeat three times, and so you can repeat r times, mean all times you can repeat. So what will be the next one? So you see here, very simple. When you take the first object, when you select the first object from this given n objects, you have now n number of options. N number of options. That means the first place can be filled up in n ways. And since the objects can be repeated, which object is used in this place can be reused in the second place also. That means the second place can also be filled up in n number of ways. Similarly, both the objects used in the first and second place can be again repeated in the third place also. That is, the object will not decrease this time again. Again you have m number of objects, so total n ways you can fill the third place also. In the similar way, all the places you can fill in n number of ways, and there are r number of times, so it will be is equal to n into n into n into all this jobs should be completed. So this is equal to n to the power r only. So this is also permutation, but when you are repeating the objects, then you should use n to the power r formula. But when you are not repeating the objects, then you should use npr formula. Is that clear? When you are not repeating the objects, you should use npr formula, and when you are repeating the objects, you are to use n to the power r formula, where n is the number of objects provided and r is how many times you can repeat the objects. That is the number r. So I think it is clear to you. So this is the proof. Already I have written in the pen paper mode, so you write in your copy this one. So now permutation of objects, not all different. This time the given objects are not different. Given objects, they are not different. So what is that? Given objects are not different. Mean, say you have n number of objects. Some of the objects are similar type. Say you have 10 number of objects, and out of 10 objects, say 3 are marble, same type marble. Say 4 are pans, same type, same color, and rest are different. This is one of the way. Or all these 10 objects, 3 are same, then say 5 are some other kind, these 5 are same, and the rest of the 2 are some other kind, So here sum of these objects is equal to 10, but here the number of objects, sum of the number of objects, repeated objects, these are not equal to 10 because these rest are different. I am writing here rest are different, but these are identical objects. 3 objects are identical, and here 4 objects are identical, but the rest are different. And here 3 identical, 5 identical, 2 identical, all total this is 10. So if you have n number of objects, say p of them are same kind, then q of them are same kind, then the total number of permutation where p and q are p are same type and q are same type, such that p plus q, you see here, such that p plus q is equal to n, then the formula is factorial n divided by factorial p into factorial q. The objects which are same, how many objects which are same, you should divide the total number of permutations by this factorial of that number. Say 3 are identical, so divided by factorial 3, 4 are identical, divided by factorial 4, in this way. Okay, so you see the notes here, you write yourself. So the number of mutually distinguishable permutations of n objects, these are number of objects, n number of objects, taken all at a time. You are taking all of them at a time, of which this p are alike of one kind, q are alike of second kind, there may be r are alike of third kind, it may be there, but I am writing for only two types of objects, p are alike and q are alike of the second kind, such that the sum of this p plus q is equal to the total number of objects. In this case, the total number of permutation is factorial n divided by factorial p into factorial q. In the similar manner, if p plus q is not equal to n, in that case also the formula will remain same. That is the number of permutation of n objects taken all at a time, of which p are alike of one kind, q are alike of second kind, and the rest are distinct. The rest of the objects are distinct. They are different objects. Then also the formula is same. So that is factorial n divided by factorial p into factorial q. If there are more objects of similar type, say r number of objects are same again, so into factorial r will be there. Is that clear? So these are the two formulae, actually theorems type. So we should use these two theorems in the solution of problems of the chapter permutation. So the next topic is circular permutation. What is circular permutation? Circular means this time the object should be placed in a circle. The object should be placed in a circle. You see here, if you have some objects, say three objects are there, one of the object is placing here, one is placing here, and one is placing here. Say the objects are say A, B, C. Then the number of permutation is what? In this case, you see, you may have this permutation. If you start with A, that is A, B, C is one of the permutation, or you may have A, C, B is another permutation. There will be only these two permutation if you start with A. If you start with B, then you will have the permutations B, C, A, or B, A, C. These are the two permutations. Object number 3, I will write the formula also here. Then the circular permutation, that means you are to place the objects in circle, not in linear. But in the previous section we discussed about the permutation of objects which are taken in linear basis. That is, objects are placed in linear format, here, 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 in this way. But in case of circular permutation, the object should be placed in circular manner. So there are two ways, either anti-clockwise way or clockwise way. Two ways. Starting from any one of this. If you start with this A, then this is one type of permutation and this is the other type of permutation. Okay, so first of all you write the formula, and after that we will prove that formula. The number of circular permutations of n different objects is factorial n minus 1. If you have n number of objects provided, then total circular permutation can be obtained from this n is n minus 1. That is, just in the previous screen I have taken 3 number of objects. So total permutation will be factorial of 3 minus 1 is equal to factorial of 2, and factorial 2 is simply 2, and that is why I obtained 2 permutations only. So this is the formula. If you have 4 number of objects given, different objects, and then it will be equal to if you have 4 number of provided objects, if you place in circle, then you will have factorial of 4 minus 1 is equal to factorial 3 is equal to 6 different permutations are there. 6 different permutations. So some of which are clockwise permutation and other are anti-clockwise permutations. Okay, so whenever you have n number of different objects, then the total number of permutation is factorial n minus 1. And how it is n minus 1 I will discuss just later on. You see here You see here. But in case, oh sorry, one thing actually you see. Say if you have 4 objects, then number of circular permutation. Circular permutation number is what? It is factorial of 3. 4 minus 1 actually. But number of linear permutation, this is linear. Linear permutation means usual permutation. Linear permutation, this is simply factorial 4. Here we will have 24 number of permutations, and here we will have 6 permutations in case of circular, and in case of linear there are 24 permutations. So this is the slight difference between the circular and linear permutation. Now try to let me solve this, the proof part of this. First of all, we say consider n number of different distinct objects, a1, a2, a3 and so on up to an. If you have a1, you see here I am considering here a1, a2, a3 and so on up to an objects. These objects are considered here. Then how many linear permutations? So let me take, there are x circular permutations. Let me take, there are x circular permutations. Then first of all, from one circular permutation, how many linear permutations can be obtained? First we will find that one. We will consider just one circular permutation. Say here a1, then a2, then a3, in this way, here a4 say, and so on. Finally it will be a n minus 1 and then a. If you erase an, if you say break up this circle here and stress and open it, break up this circle here and open it, then what will be the linear permutation? Say break up here, not there, break up here. So the linear permutation will be, in this case, is a1, a2, a3, this way, a1, a2, a3 up to an. See there, sorry, I am erasing this. Let me take the any one of the circular permutation, any one of the circular permutation. I am taking here any one, and say it is beginning with a1, here it is a2, it is say a3 and so on, say it is a4 and so on. This is say a n minus 1 and finally say it is an. Now cut this circle here and open the circle. Then what is the linear permutation? Is it not a1, a2, a3, a4 and so on, a n minus 1, an? This is one linear permutation, first linear permutation from a single circular permutation. Then if you cut this circle here and open the circle, then you will have the corresponding linear permutation starting with this time a2, a3, a4 and so on. It will be an, then a1, it will finish at a1. Similarly, if you cut here, then again open it, then this time it will begin with a3, a4, a5 and so on, a1, a2, finished, and so on. In this way, if you go, finally if you cut here, then it will begin with an, then a1, a2 and so on. Finally it will finish at an minus 1. See, we are considering here a single permutation, circular permutation, one single permutation, circular permutation. And from a single circular permutation, how many linear permutation obtained here? You see, this is one linear, 1, 2, then 3, 4, 5, 6 and up to n. So from one linear permutation, I am getting n, sorry, from one circular permutation I am getting n linear permutation, and from x circular permutation how many total linear permutation? It will be x into n only, is not it? From one circular there are n linear, so from x circular it will be n into x linear. But you see, if you have n different objects, then total linear permutation formula is simply factorial n. It is in the first part of this topic, permutation. So this factorial n, it is the number of linear permutation, and this nx is also the number of linear permutation. So these two terms are equal actually, and using that result we will have the formula of number of circular permutation. You see that result only. So let A1, A2, A3 and so on up to An, this is the n distinct objects. Let the total number of circular permutation is obtaining, say, x number of permutation will be there. Let us consider of these x permutations, let us consider one of these, any one of these x circular permutations in the figure here. So clearly from one circular permutation we will get this linear permutations. This is one of the linear permutation I just discussed with you. This is first linear permutation, then this is second one, this is third one, and so on, and this is the last one, last circular permutation, is it? And you see here, from a single circular permutation I am getting here n linear permutations, but we have how many number of circular permutations I am taking? I am taking x number of circular permutations. So from 1 we have n linear, so from x we will have nx linear permutations. Okay, so then you see the next slide. This one. Thus each circular permutation gives n linear permutations, but we have x circular permutations, so we must have total linear permutations is x into n or n into x. But the number of linear permutations that is obtained from n objects, you forget about this. You just have now n objects and number of linear permutation. It is obviously factorial n. You know this, obviously factorial n. So this is the total number of linear permutations obtained from n objects, and this is also the total number of linear permutations obtained from n objects. So obviously this xn or nx, this nx is equal to factorial n. So I am finding the value of x. What is x? So it is factorial n divided by n. But factorial n, from factorial n, if you take, this is implies x is already here. From factorial n, if you take n outside the factorial n, then it is simply n minus 1. Divided by n is already in the denominator. These two n's are cancelled. So you have only x is equal to n minus 1 factorial. So from n objects, different objects, you will get x is the number of circular permutation I have taken already, and x is equal to factorial n minus 1. So from n different objects we will have n minus 1 circular permutations. So that is the proof of the theorem. So that is written here. So you see, in the above theorem, I already told you this one. In the above theorem, anti-clockwise and clockwise order, these are considered distinct. That means anti-clockwise different permutation, clockwise is different permutation. That is indicating here. And the second one, the clockwise, if the clockwise and anti-clockwise order of arrangements are not distinct mean clockwise is clockwise and anti-clockwise, if they are same, then the number of permutation will be half of the total permutation. You see here, that is, you see here, yeah, this one, say it is 1, 2, 3, then 4, 5, and then 6, then 7. These are distinct objects, distinct objects. So in this case, the circular permutation number 6, that is 720. But if the objects are same in clockwise, here clockwise is 1 2 3 4 and anti-clockwise 1 7 6 5 this, so they will represent different permutation. But here I am telling about this one. You see, telling about if the objects are like this, say here is A, B, here is again B, this is C, it is C, this way. That is clockwise ABC and anti-clockwise is also ABC, these types. So if these types are there, then the total permutation number will be half of the total permutation, because they are not distinct. These and these are same. If you go clockwise, anti-clockwise, and if you go clockwise, will be same, and same should not be counted 2 times. Therefore, it will represent half of the total number of permutations. I think it is clear to you. So this is the end of the theory part of the topic permutation, and in the next class we will do some problems of permutations, related problems of permutations. So we leave this class here. Thank you very much.